This is a quick tutorial on the modulo operator and how we can apply it within the context of our project. So just to give you guys some context here, this first plain text matrix is the phrase good space morning spelled out. So remember, we go from top down and then left to right. Typically we read things left to right then top down. This is where it's flipped. Remember, the 7 is a G, 15 is an O, that's an O, D, space, M, O, R, so on and so forth. I'm not going to show you guys how to actually calculate from the plain text to the ciphertext because you have that in the project. What I'm really talking more about is what the modulo operator is and why that's super useful when we get to this point in time. So let's pretend that I go from the plain text and I end up with this ciphertext matrix here. Now you'll notice that this is very possible where, let me just fix this real quick for organizational purposes. You'll notice that these numbers are way bigger than 26. We have a nice little key here to help us out. 0 is space, 1 is A, 2 is B, all the way down to 26 is Z. But what happens if you get a number bigger than 26? And I should probably say 28 because I'm blanking out and I forgot we added these two characters last second. So it should really be 28. After 28, what is 29? And this is where we need to think about a cipher. What this should do is loop back around itself. So 29 actually goes back to space. And then that means 30 is equal to A. And you can rinse and repeat this process over and over and over again. The issue with doing this manually is that it's going to take quite a while to get to a number, say, like 144 or 123. Is it hard? No. Is it tedious? Yes. Do we like to make our lives a little bit easier? Absolutely. So this is where the modulo operation comes into play. So I'll just type it out so you guys have it. It's the modulo operator, or operation, whatever you want to call it. So here is how the modulo operator works. We're going to go over to Desmos to let the calculator do the work for us. If you say you have an idea such as something like 10 divided by 2, that's a very straightforward concept. You have 10 items divided equal into 2 groups, or another thing about it is how many groups can you make that have only 2 items inside of it? That's pretty straightforward. The answer is 5. The modulo operator takes this and does the same operation, but looks at it from a slightly different perspective. We're going to do the exact same thing. What this is doing here is it's saying, hey, when you take 10 divided by 2, what is the remainder? Maybe this rings a bell back from 5th grade when you did a ton of things where you divided numbers that weren't easily divisible by the second number, and therefore you had what we call the remainder, right? Because 10 divided by 2, there is no remainder. You get the answer 5, right? But if I change this up to 10 mod 3, we now get a remainder of 1. Think about it. How many groups of 3 can you make? Well, I can make one group of 3, I can make a second group of 3, I can make a third group of 3, that's 9 total. I have 1 item remaining. We can also think about it like this. 10 divided by 3 gives us 3.333. Or in other words, isn't that the same as 3.33333? Or, I just wrote the same thing out, so I just apologize for that. Isn't that the same thing as 3 and 1/3? Or 3 and 1 remaining before making a third group. Or another group of 3s, I should say. So this is the idea of the modulo, where the idea is you take the first number divided by the second number, and answering the question, what is the remainder of doing such an operation? This is pretty easy when it comes down to numbers that are smaller than the divisor. So suppose this is like 2 and this is 3, so it's 2 divided by 3, and what's the remainder? Well, you can't divide 2 by 3 and get a nice number, so the remainder here is 2. Whereas if I say something like 16 divided by 3, well, I know I can do 15 divided by 3, and that gives us a remainder of 1. Another way to also look at this as well, if I go back to the 10 example, is I can basically say start with 10 and just keep subtracting the second number until I can no longer. And notice here, I get the exact same answer as before. I can change this up, or I can say this is like 17 divided by 5. We'll do the same process, 17 minus 5, that's still too big, minus 5, it's still too big, minus 5. Okay, I'm less than 5 now, remainder is 2. These are 2 separate ways of looking at the same idea. Now, how do you do this inside of the mod ciphertext? Because again, we need to translate this into numbers that are less than 28. Yes, because there's 29 numbers total. Less than 28 such that I can now convert these numbers back into the letters as seen on the side. Well, one way to go about it is just to literally do this every single time. You take this number here, go into Desmos, type in mod 28, yes, mod 28, and then write the new number in here. If you would like to use Excel spreadsheets, because this is a part where you're going to want to be able to show your work, but again, showing the work for modulo is kind of tedious and super annoying, so totally cool if you guys do it this way. But what you can do is you can type equals mod, and then you can take the 92 and then mod it into 28. You get the answer right there. Another way you can also go about it very easily if you have a setup similar to mine. You don't have to do it this way. This is just the way I'm setting it for demonstration purposes. But what we can do is you can take this number, and reminder from the retirement project, we can do dynamic cell referencing, where I can reference the cell, take wherever this is in cell, and mod it by 28. Hit enter, same exact answer. And I can do a nice little trick here where if I do something with this bottom right-hand corner, hopefully you guys remember from the project. If not, no worries. We can drag this over and it might, copy the cell over. Worst case scenario, every cell, you just manually reference it. So here you can say equals this cell, or actually say mod of this cell, comma, 28 never changes. And so we can go from there. Maybe you can highlight these two cells, do something with it, make it so we can do everything here. Makes your life a little bit easier. That being said, you still need to show your work when you're going about the process of going from the plain text to the final ciphertext. But this part right here might be helpful and useful to be able to use the modulo operator both in Desmos and in Google Sheets to help you guys out from here.